I'm going to talk about object and oriented design plus the system structure of Myriad Medical Services. This is the medical management system which we created during our CMP 7001 module. The major goal of project was to transform to old MMS and create a strong, easy to update software solution that handles the main operations like scheduling patients, assigning doctors and charging. The current MMS system did not support crucial business processes and was poorly structured, which made maintenance and extension very hard. Thus, the following was our primary object to create a console-based multi-user system in Java to follow the object-oriented design OOD principles completely. To offer, among other things, polymorphism, support, exception handling, and structured command line interface. We proposed to create an OOD system with layers that are easy to maintain, scale, and upgrade. My specific input accounted for the three main responsibilities: class diagram construction and refinement. I worked on the creation and improvement of the UML diagram which indicated the different classes of the user, patient, admin, clinician, and manager and their inheritance relationships and behaviors. In carrying out of this task, I followed the OOD principles, particularly the single responsibility principle along with the encapsulation and inheritance exception handling foundation. I formulated domain specific exceptions, namely user not found exception, invalid treatment state exception, billing not ready exception. With these user defined exceptions, it was easier to handle the errors without affecting the system robustness. CLI system architecture. I was in charge of the menu navigation system that comprised login flow, role-based menus, user interaction loop. The goal was to create a system that was both easy to use and consistent, as well as that would allow for further future expansion. These contributions altogether led to clean architecture and reliable interactions and a well-organized design workflow overall. Before the system was designed, we figured out the essential functional requirements by means of diverse actors like admin, patients, and clinician. Main use cases are such as scheduling of appointments, logging, logging treatment, assigning clinicians, and billing generation. Non-functional needs like dependability, protection of data, and expansion of the system. Prior to the systems designing, we established fundamental functional requirements by actors, admin, patient, clinician. Main use cases: booking, recording treatment, allocating clinicians, and issuing bills. Non-functional requirements like reliability, data security, and system scalability were also considered. The system comprises of three primary actor types that interact with each other. Patients schedule treatments and gets notification. Clinician see distincted patients and document treatments. Admin enroll patients, assigns clinicians, and manage finances. Every actor engages with a particular group of use cases which maintains the division of duties and limits at the overlapping of roles to a minimum. Single responsibility principle SRP was one of the main design principles that got the most attention. To give some examples, patient data only related to the patient. Appointment manager only deals with the appointment logic. Persistent manager just takes care of the CSV file input output. Clinician only documentation concerning treatments. This has positive effect on the system testability, maintainability, and clarity. Encapsulations was very important for the reason that MMS deals with the delicate healthcare data, how encapsulation work implemented. All classes have private attributes. Data can be changed only through getter setter methods. Updates to treatment states are permitted only via the appointment manager. Role specific activities are only allowed through the control interfaces. Reasons for the importance of encapsulation in the situation: safeguard secret health data, restricts the occurrence of the invalid or dangerous workflow, facilitates system maintenance and evaluation in the future. The use case diagram visualizes how each actor interacts with the system. For example, the clinician interacts only with the view allocated patients and record treatment. Patients interact with the booking and notifications. And the admin has access to registration, allocation, and billing operations to ensure clarity and enforces role-based boundaries. The system is divided at the structural level into service or manager classes and user hierarchy. Service or manager classes. These consist of managers for the business logic like appointment manager, billing manager, and persistence manager. User hierarchy. We devised an inheritance hierarchy. User abstract. Patient, clinician, admin. In this way, we could use shared characteristics such as user ID, name, email, password, role, and at the same time, we could use polymorphism to override role specific methods. Mostly polymorphism was realized via dynamic dispatch at runtime. A sample in the user parent class, the abstract method display CLI is there. The subclass patient, clinician, and admin each provide their own implementation to show their specific CLI menu. Thus, the system is able to invoke user.display CLI method, and the proper menu shows up according to the real user type. Cleaner, more extensible code and easier future edition and are the consequences of this. The use of both API exceptions and customized ones is traded upon by the system. Checked exceptions as an instance, the persistence manager is in charge of IO exceptions for file operations. Custom exceptions. The part of domain logic needed safeguarding was their purpose. Invalid user credential exception, treat already accessed exception, appointment not found exception, workflow exception, exception flow, an error occurs, an exception is raised, the manager layer catches it, a user-friendly message is displayed by the CLI, the system keeps on working safely without crashing. Thus, the usability and robustness of the system are improved greatly. Design pattern. The persistent manager employs the data access objected pattern to segregate data management from the logic of the application. Advantages. Migrating from CSV to DB becomes easy. Code turns out of the modular. Testing it easier. Unit testing. Our core logic such as doctor assignment, changes of the state of treatment, conditions of throwing exceptions was subjected to JUnit testing. One significant design challenge was how to enable clinicians to see all their patients while uploading SRP. To overcome this, the appointment manager applies the clinician ID to filter the appointments. The clinician class is responsible solely for the presentation logic. No data fetching duties are imposed on the clinician class. The approach maintains SRP and at the same time delivers the desired future. Most valuable technique. SRP was of great value because MMS involves different user types having access to certain fields but performing different operations on them. This allowed the software to be written in a cleaner way as it don't mix up with the operations and had a departments of the system very well specified. Most challenging technique. State management. It was the hardest thing to do, managing treatment state transitions across several managers. classes while trying to keep the workflow safe and consistent. We had to make it clear that a treatment would not be accessed more than once or that the updates enacted would not be in invalid order. To sum up, the MMS system is completely in the line with object-oriented design principles, safe and trustworthy due to the applications of encapsulation and exception handling, open to modification through the use of inheritance, polymorphism, and clean architecture, easy to manage because of the applications of SRP and the DAO pattern. On the whole, the project ended up like with this a system that was functional and well structured and met all the design requirements. Thank you.